Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel about everything I want to talk about math and science. And we're adding to the chemistry measurement notes. So there you go. That's what this video is. I actually have hundreds of videos on YouTube. So I have to sort of tell what it is so that if I go back and look at it, I know what video it is, what playlist to put it in, and all of that. I've told y'all that though, right? About my YouTube channel. So anyway, so this is chemistry measurement, unit 1, and we've done the notes, but I was looking over the test stuff, and there's a couple of things we need to emphasize or talk about. One is the scientific method. It's like, how can you ever have a science class without talking about the scientific method? Now, my son Eli is very passionate about that. He thinks that we waste a lot of time in science talking about the same things over and over again. He's like, you should learn it one time, and then why do you have to learn it in every single class you do in science from then on? It's just dumb. And I sort of am starting to agree with him a little bit, because you learned the scientific method in elementary school, and you learned step 1, step 2, step 3, step 4, and real scientists don't do that. So it kind of gives kids a false sense of what real scientists do. What real scientists do, they don't go through the scientific methods, go to work each day. Okay, which step am I on? Oh yeah, I'm on step 3. What real scientists do is they do science in a systematic way, and they record things with systematic measurements. And there are certain rules about how you do it. Things like that when you do an experiment, you don't manipulate more than one variable at a time. So or otherwise you don't know what is causing the result. Now, I know this. I have a degree in science, not education. My degree is in science. But if I get sick, I throw it all out the window. Instead of just trying one thing to see if it makes me better, I will try anything anybody suggests to me. Oh, you should try putting Vicks VapoRub on your feet. Great. VapoRub on my feet. Oh, you should take emergency. Great. Emergency, taking it. You know what always works is if you take a lot of vitamin D. Great, taking vitamin D. And so at the end when I get well, I don't know which of those variables actually helped of these homeopathic methods. One time I was tutoring some kids, and one of the moms that I tutored, she said, oh, you seem kind of sick. Here are some pills. She hands me a handful of yellow pills. No idea what they are. I took them. Now, you should never do that unless it's someone you really trust. And I knew this other mom of this teenager. She wasn't giving me drugs. It was something she had bought in the vitamin part of Kroger. So I knew that it was, not illegal or whatever. But do I know if that's what made me well? No. And can I do it again? No. I don't even know what it is. But whatever it was, I took the extras. I had this little thing that I take when I tutor. It's this little thing, and I threw the extras in here, and for a long time, oh, there's one here, you can see the yellow pill, there it is, but I don't know what they are. They're turning brown now, but whatever it is, my cats would go crazy over them. They would just try to get it so bad, so I'm thinking it was catnip, but I don't know. I got better, so I didn't die. I'm better now. So anyway, the scientific method, in reality, scientists don't do step 1, step 2 like you memorized, but it is a systematic approach used in scientific study. You want to be systematic. You don't want to just throw everything at the wall and see what sticks, because then you don't know what it really was. So make a little note. It will be on the test. The scientific method. So just write a little note. There'll be something about the science. Oops, I got it right. There'll be something about the scientific method on the test. So make sure that you write that down. And the big key word is that you want to have a system. A system in place that you're going to follow as you approach scientific problems. But it's not really step 1, step 2. Okay, so that was the first thing while I was reading over the test. I thought, I didn't really talk about that. The next one is units. that we need to add a little bit more to, and that we had, and I did this, but I didn't really, and I talked about dimensional analysis, but I didn't use this word. The key word is derived units. You can turn it in, Haley. Just put it up here. That units, you can have regular straight units like grams or liters. Those are just straight basic units. But when you do math, remember how when we solve for density, we put in the units. We put in grams on top, and we put in milliliters on bottom. So the units of density is a derived unit. The unit of density is grams per milliliter, or it is a mass unit over a volume unit. It could be cubic centimeters or something like that. But its derived units are going to have math symbols in them. They're going to have fraction bars. They're going to have letters sitting next to each other, meaning multiply. And sometimes they even have the little multiplication dot in them. So you'll have things that are squared or cubed. So derived units have had math done to them, and we write the math symbols in the derived units. Any questions about that? Does that make sense? You're good with that idea? Okay, and that's the whole idea of dimensional analysis, is that you do the math to the units too, and you can tell if you did the math right. Derived units, okay. All right, now, the next thing. Let's see if I can go down some since I used all my writing place here. It kind of makes you feel sick when it moves that fast. It's more fun with sound effects. All right, there's a place to write. Okay, so the next thing is error. One of the things we do as good scientists is we want to know that accuracy and precision idea. How close are we in accuracy to the truth? And one way we do that is we figure out the percent error. So write this down, percent error. Okay, so how you get it is one of the things we do. Remember how I said that labs are very picky? And it's almost like a haiku poem, and you have to do it a certain way. And it has to include certain elements. And one of the elements that you want to include in the lab is you want to have error analysis. You want to analyze as part of your lab write-up, and that's sort of like our papers in science. You want to write up how good is your lab? How close did you get to the truth? What sort of data did you generate? So on our Metric Olympics, what we did is we made where we estimated, then we really did it, so we can figure out the error. And how you do that is it's the absolute value. Do y'all remember absolute value from math? Do you know what absolute value is? What it is here is we're just not really gonna, if it's negative, we take the negative away. There's more to absolute value than that, but you can watch my other videos if you want to. Okay, so we're gonna take the actual minus the experimental, the absolute value, divided by the actual times 100. Okay, actual minus experimental divided by actual times 100 is how you can get the percent error. My little pen came apart. All right, does that make sense? So on your lab, you would have guessed how many marbles you grabbed with your left hand. You write it down. I guessed 500 marbles. You count them, see what they are. So then it was really 250. So then you would do 250 minus 500. This one, our experimental for your lab is your estimate. So what you're doing the difference between is what you guessed you were going to do and what you really did. Okay, and then divide it by the actual times 100. Now, normally in science, this percent is going to be, we're also going to do it with percent yield. So percent yield is something that we'll talk about too. Let's write that one down too. percent yield, and we'll come back to this one later. For percent yield, it's the absolute value of the expected minus the experimental absolute value divided by the expected. Expected is like actual, and then times 100. I'm running out of room. Right, 100 right there, times 100. It's really the same formula, just applying it to a new thing. So usually your percent error is like maybe a little bit, like maybe you're 5% off or something like that. With your percent yield, it's usually less than 100. So like when you're making an experiment, you're expected to get a certain amount of product, but you end up getting less, then that's what it usually is. You usually get less product than what you're supposed to. If you get more product than what you were supposed to in your experiment, it means you have something in there that's not supposed to be there. Either you got some trash in it, but more likely you didn't dry it out good. Usually when you're over 100% with your percent yield, you've got water in it. Water is the trash that's not supposed to be in there. All right, so does that kind of make sense? How to get these errors and how to do that last little bit of math kind of thing. Now, this is probably not going to be on this test, but it will be on other tests and it will be on other labs. And while we're talking about measurement and chemistry, I thought we should just go ahead and throw it in so that y'all know it. Okay, see if there's anything else. Derived unit, moles, percent error, molar mass. Okay, I think that's it. So I'm going to stop the video. So those of you who are not in class, now you've got everything, all of the information that will be on the test. So be sure to study it and check Canvas for dates. All right? Science is great.